Hello everyone, welcome to the very first step on your journey to Java mastery. If you're just starting with Java or any other programming language, you might be making a huge mistake. Most beginners jump into coding without understanding the fundamental concepts of computer science. That's why 90% of them struggle and eventually give up. But don't worry, in this video I will show you exactly what you need to understand before you write any single line of Java code, setting you up for a long-term success. Let's dive in. The goal of this course is to take you from a complete beginner to a confident Java developer by building a strong foundation, both theory and hands-on practice. By the end, you will not only understand Java's core concepts, but also be able to write real-world applications with confidence. Let's go over how this course is structured. Each video will introduce a new Java concept, followed by a hands-on practice session. When needed, we will also work on small projects to reinforce learning. All practice exercises and project files will be provided in a downloadable PDF linked in the video description. This course is divided into 4 modules covering Java from basics to advanced level, with a strong focus on hands-on practice. The first module will be thinking like a computer scientist, which will make you understand how things are working internally. The second module will be key Java concepts, where you will learn basic syntax about Java, data structure, object-oriented programming, and etc. The third module will be advanced topics, which we will cover file manipulation in Java, multi-threading, and also databases in Java. And last module will be final project, where you can practice all what you have learned throughout the course. So let's get started. In the first video, we are going to cover 3 key things that every beginner must understand. The first thing will be the real difference between coding and computer science. The second, how Java actually works inside your computer. Last but not least, the biggest mistakes beginners make and how to avoid them. And finally, we will get hands-on with a mini project where you will install Java and write your first program. So let's explore now what is the difference between coding and computer science. So simply coding is like learning to type words in a language, but computer science, it's understanding how that language actually works inside a computer. Imagine trying to cook without understanding heat, ingredients, or measurements. That's what happens when you jump into Java without learning the basics. And that brings us to our next important topic. Imagine you are a foreign student traveling to a new country. You need to communicate with the locals, but you have 2 ways to do it. Scenario 1, using an interpreter, you arrive without knowing the local language, so every time you speak, a translator helps you communicate, sentence by sentence. They translate what you say in real time. This is exactly how an interpreter works in programming. It reads and translates code line by line while the program runs. Scenario 2, learning the language beforehand. Now imagine you prepared in advance. You took language classes, learned the customs, and when you arrive, you can speak fluently without needing a translator. This is how a compiler works. It translates the entire code into machine language before execution, allowing the program to run smoothly and efficiently. So in summary, the interpreter translates on the go, like a live translator. A compiler, on the other hand, translates everything in advance, making execution faster. Both approaches enable communication between programmers and computers, but they work differently. Now that we understand this, let's take a closer look at how Java works. Java is special because it combines both compilation and interpretation, giving it a unique advantage over other programming languages. So, step 1. Compilation into bytecode. When you write Java code, it first goes through a compiler, which converts it into bytecode, a special intermediate language that isn't tied to any specific operating system. Step 2. Interpretation by the JVM. Instead of being executed directly by the computer, this bytecode is passed to the Java virtual machine, which we call JVM, which interprets it into machine code at runtime. This process allows Java program to run on any operating system that has a JVM, whether it's Windows, Mac, or Linux. So you might wondering now, what is bytecode and what is the JVM? So think of bytecode as a universal translation of your Java program. It's a compiled and ready for execution, but it needs a JVM to interpret it into machine code that your computer understands. So let's explain now what is Java Virtual Machine. The JVM is the key to Java's cross-platform capability. It takes bytecode and translates it into native machine code specific to your system it's running on. This means you can write Java code once and run it anywhere, a powerful feature that sets Java apart from many other languages.
So this process allows Java to run on any operating system, Windows, Mac, Android, or Linux, without modification. Unlike C or C++, Java is designed to be portable, write once, run anywhere. Now that we understand how Java works, let's address one of the biggest challenges beginners face. Now, 4 mistakes beginners mostly do. The first one is skipping the fundamentals, not understanding variables, memory, and how computers execute code. The second mistake, copy-pasting code without understanding. You won't learn by just copying code from Stack Overflow or let ChatGPT write it for you. The third mistake is giving up too soon. So debugging is part of the learning process. Errors are your friends. So the fourth point is learning 2 languages at the same time. So beginners will end up not learning any of the languages because their concentration divided into 2 sections.
Before we start writing Java code, we need to set up our development environment. Java requires the Java Development Kit, JDK, to compile and run programs. Here is how to install it. So first, go to oracle.com/java and download the latest JDK for your operating system. Run the installer and follow the setup instructions. Last, to confirm the installation, open your terminal or command prompt and type java --version. If Java is installed correctly, you should see the installed version displayed. Great! Now that we have Java, let's set up our IDE. An integrated development environment, which is called IDE, helps us write, debug, and run Java programs efficiently. IntelliJ IDEA is one of the best Java IDEs. In order to install it, go to jetbrains.com/idea and download the community edition. It's free. Second, run the installer and follow the setup instructions. Once installed, try to launch it and also try to create a new project. Now let's write our first Java program. Open IntelliJ and select a new project or choose an existing project. So when you create a new project, you will have a source folder. Inside the source folder, you need to create a new file and name it whatever you want. I will name it helloworld.java. And then you write the following code. You write a class, which we will know about it later, And inside that class, you write the main method, which is the entry point for any Java application. Now let's write our first program. So system.out.print new line hello Java. Click run and you should see in the screen hello world as you see right now. You have just written and executed your first Java program. It seems simple, but this is the foundation of everything that we are going to learn throughout the course. If you found this video helpful, like, subscribe, and hit that bell for updates. Drop a comment if you have any questions. I'm here to help. See you in the next lesson, and happy coding!